Okay, so here you see trigonometric integrals part 3. I'll probably have to make one more video after this one to show you everything, but I don't know, this may do it. Let's see how this goes, and then there might be a fourth part that comes after this. So in this video, I'm deviating from what we were talking about in parts 1 and 2. In parts 1 and 2, I had talked about this particular problem where you have mixed powers of sine and or cosine. Okay, and there were two cases depending on whether the powers were odd or even. All right, and that's what we've done so far. Now I just want to extend that to, in a very general way, to the point where if you had tangents and secants and cotangents and cosecants and other trig functions. All right, so we'll look at the first one and maybe make a brief comparison to the second one. All right, what do you think about this? How would you do this one? Well, one thing that strikes me when I see this is that the derivative with respect to x of tangent of x is secant squared of x. So when I look at a problem, I'm thinking about what are the derivatives of the things that are involved? Are there any identities with, I could say tangent sine over cosine or something like that, just to see if I can get something I recognize. Okay, now if I notice this, the derivative of tangent secant squared, then I think, well, then if that's the case, I can let this be u and that be du, and it be u substitution. Okay, so here's what I mean. Here's what I think we're going to get to work for this one. We'll let u be tangent of 4x. All right, and then the du will work out with more or less what you see there, secant squared 4x dx. So if u is tangent 4x, what's du? It would be 4 secant squared 4x dx. That's by the chain rule, where the 4 shows up, okay? So du over 4 will be secant squared 4x dx. Okay, so here's how this one is going to work. With my substitutions, I'm going to have to divide that 4 over there, but you've seen plenty of u substitution by this point. If I do that, then in this step I'm going to get u tangent 4x secant squared 4x dx. That's going to be du over 4. So I'm going to get like that, and then I get something that should be pretty easy. I take out this factor of 1/4 right there, and then I'm left with u times du, right? Okay, so yes, that the u substitution, once we recognize it, it turns it into a pretty easy problem. Our answer, 1/4 times u squared over 2, all right, that is the antiderivative of u to the first power, u squared over 2, plus c, so I'll get with this one, 1/8, u is tangent, so I want tangent squared 4x, all right, and then plus c. Okay, not too bad. Like if we recognize the technique, it's not too bad. All right. Okay, now this one is more difficult, but it's not like it has nothing to do with the first one. But we're gonna have to make some more connections to do this one. All right, we're gonna have to realize a few things. So let's say we're looking at this. We're trying to figure out a way to do it. All right, this will take some practice on your part. It takes some trial and error, but that's the way Calculus 2 goes. All right, let me try, and how about this? Let's just get some things on paper about what we're dealing with, cotangent and cosecant, okay? So let's see, this is just stuff that we're thinking about. Okay, kind of like a brainstorm on what we could use. So it's true, here's an identity, 1 plus cotangent squared of an angle is cosecant squared. Oops. Okay, maybe we can use that. Also, what about the derivatives of these things? Okay, so the derivative of cotangent is negative cosecant squared. Okay, And then the derivative of cosecant is negative cosecant cotangent. Okay. And then let's see if we could get this to work somehow. All right. Like maybe cosecant squared could be the du. Or maybe cosecant cotangent could be the du. All right. Okay, so that's what I'm thinking when I'm looking at this one. Now, I think that, we could try to make that be the du. I'm inclined to think that won't work, though. So let's see about this. Could somehow we separate one of the cotangents and one of the cosecants and get that to be the du somehow? And then cosecant will be the u. All right, so that's what I'm thinking. Let's see if we can get it to work, though. So suppose that I borrow one of each of these away, okay? And I get cotangent to the fourth power, cosecant to the fourth power, and then, I'll put this in parentheses, cosecant x, cotangent x, dx. Where I'm thinking maybe I can get that to be my du. Remember, that's what I was saying over here. Okay? All right. Now, if that was going to be the du, the u would be cosecant. Is there any way that I could turn all of this to just be in terms of cosecant? Is that possible? All right. Well, cotangent squared is cosecant squared take away 1. And I think that's our ticket. All right? Because if I'm going to get this to work, the du is going to be this cosecant and cotangent. And the u is going to strictly be cosecant somehow. Cosecant to different powers and so on. Okay? All right. So let's do like this. In order to put this strictly in terms of cosecant, I'm going to get cotangent squared in this format. Cotangent to the fourth power is cotangent squared squared, right? Okay. And then I'm still going to have this cosecant to the fourth power. And then I'm going to have the cosecant and the cotangent. All right? Then from here, with, again, the objective being to put this part completely in terms of cosecant, I'll say that cotangent squared is cosecant squared minus 1. Then I'll get cosecant squared x, take away 1 for that, squared cosecant to the fourth power. And then that's going to be the way that I want it, basically. I got, unfortunately, more algebra to do, but for the most part, I've got it, and I can tell that it's going to work from here. Can you tell it's going to work from here? What are you going to get once you multiply all this out? Powers of cosecant. Okay, well, that will be our u. And then is that going to be du? Well, yeah, the derivative of cosecant is negative cosecant cotangent. All right, so here it goes. Time for some algebra. So multiplying all that out, I'll get cosecant to the fourth power minus 2 cosecant squared plus 1. All right, I'm going to take that times cosecant to the fourth power. And then I'm still reserving this part to be the du in my anticipated u substitution. Okay? All right, so yes, now that I'm here, multiply all that together. Okay? All right, and then I'll get what I anticipated from the beginning. Okay, the cat's walking on the desk. All right, come on. So anyway, I'll get here cosecant to the 8th power minus 2 cosecant to the 6th power plus cosecant to the 4th power. All right, that's where I was hoping to get when I wrote this in red ink. Just thinking I could get there, and now I'm there. All right. Okay, so cosecant x cotangent x dx. That will be my du. All right. Now for this part, I just want to put a note that we'll let u be cosecant x. So that's going to look like u to the 8th power minus 2u to the 6th power plus u to the 4th power and so on. And du will be negative cosecant cotangent x dx. Okay? So now we've done so much u substitution. I'll leave it to you to put that in there and incorporate the negative the right way. But here's what you'll get, all right? Once that's u to the 8th power and so on, right? Once you do that, you'll get minus cosecant to the 9th power over 9 plus 2/7 cosecant to the 7th power x minus 1/5 cosecant to the 5th power x. That's after that u substitution is incorporated in there, all right? But we've done, like I said, we've done lots of u substitution, so I think you can handle that. If you can't, you can always ask me about it. And there's my final answer. Finally, all right? Okay, so we got that one, and I think that that is just kind of a mixture of a lot of things that we've seen so far. That in these problems where we use identities, we use u substitution, they're all different, but they all have a lot in common at the same time, all right? Okay, so let's put this one behind us then, and let's look at a few more assorted problems. Okay, so let's see like how you integrate tangent and secant and cosecant, okay, in case they should come up. How do you integrate tangent all by itself? Is that anything like the first problem that I did? What if I have tangent times secant squared? Well, then you're looking at u and du. What if you just have tangent? Well, if you let that be u, the du is secant squared. It's not there, okay? So with this one being the way it is, we're really just stuck with it. But what did I tell you about this other one? That you have to think about relevant identities, the derivatives of the things that are involved, and see if you can put something together that you know how to do, all right? That's really just the way it is. So is there an identity with tangent? There's a fairly easy identity, okay? Tangent is sine over cosine. That's one everybody knows, okay? All right, then I'm thinking, oh, u du, like I could let u be cosine, and the derivative of cosine is minus sine, so I get that to be du. So here's what I'm thinking. Once I see it like this, I'm thinking, well, could we get this to be 1 over u du? Okay, since the derivative of cosine is minus sine. Let's try it out. I'll separate out a little bit more. I'll say I put this as 1 over cosine, and then times sine x dx. I mean, that's the same thing, right? 1 over cosine times sine over 1. That's what I'm thinking will be this. And yes, with u substitution, I can turn this into a form of integration that I know. All right? So let's do this. We'll say u is cosine, du is minus sine x dx. Okay? So for sine x dx, we'll substitute negative du. All right? And this is what we're going to get if we use our substitutions. Rearranging that negative, putting it over here, but you know how that works now, right? We're going to get 1 over u times negative 1 times du. It's going to look like that. It's going to look like this. And that is a known form of integration. The antiderivative of 1 over u du is natural log of absolute value of u. Okay? Okay. Natural log absolute value of u. All right. That's how this form works out. Whenever we see 1 over u du, that's what it is. Okay, so let's see. Final answer. Negative. Natural log. And u was cosine. Cosine x plus c. Okay. So there's a little bit more about this one, although I have an answer that I'm happy enough with right there. So there's a rule for logarithms. And it says if we have some power times a logarithm of any base of something. So say a p times log base b of m. I don't mean p to be a power. I know I said that, but I'm just thinking ahead a little bit. So say a number p times log base b of m. The base there can be anything. It could be natural log base e. Then we have the option of applying this constant, this multiplier right there, as a power on m, okay? All right, so we've got that rule. It's one of many rules that we use involving logarithms. So that -1 right there could be the power on the cosine. What's cosine to the -1 power? It's 1 over cosine. And what's 1 over cosine? It's going to be secant. So it's also written like that, okay? Who knows which one of these you'll see, but if you saw this one, I want you to know how you get it from that one, all right? It's just with this rule for logarithms, that being a -1, if applied as a power to cosine, giving me 1 over cosine, same thing as secant, all right? So who knows which form you might see, but that's what we get. All right, so we've done tangent. Now you know how to integrate tangent if you see it. What about secant? Okay, well, so this one has a trick to it, all right? And it's a trick that most people are not going to think of. But you need to see how it works if you're going to learn calculus 2. Okay, so say I take that secant, because as it is, there's not really anything I can do with it, all right? I could say secant's 1 over cosine, kind of like I did here, but that won't get me anywhere. Identities, you know, that's not going to get me anywhere either. It's really hard to work with this one. So at some point in time, somebody thought of this. Let's see, I'm going to multiply this by 1. Is it okay to multiply by 1? It's definitely okay to multiply by 1. If you take something and you multiply it by 1, it's not going to change what it is. But the form that I want to multiply this by 1 is secant plus tangent. Okay? So just suppose that I do that. And I know that you may not have thought of that. Or you're maybe looking at this like, I would have never thought of that. Well, that's fine. I mean, I'm just telling you that suppose I do that. I want you to see how it plays out. All right? But that is just 1 right there. Okay? How does that play out? All right, well, if I multiply these together, I'll get secant squared x plus secant x tangent x. Okay, so that's how that part works out. And underneath it, I'll just get secant x plus tangent x. All right. Now, your response to this might be saying, well, this looks worse than it did when we started. How can this be any good? How can this be the right way to go? Well, this problem here, at this point, the point we're at right now, is like this one. Okay? Let's see. Remember, what did I tell you that you could do when you learn to do things like this? Think of identities that are involved with what you have, the derivatives of the things that you have, and so on. So I've got secants and tangents here. What is the derivative of secant? It's secant tangent. Okay. And then what is the derivative of tangent? It's secant squared. So look at this. I got secant and tangent. Up here I got secant squared, secant tangent. isn't the u substitution going to fall into place? I think it will. I mean, it'll be 1 over u du. All right? Let u be secant x tangent x. That top part is going to be du. We could look at this as 1 over secant plus tangent times secant squared plus secant times tangent dx. It'll be 1 over u du. Okay, all right. So derivative secant tangent plus secant squared. Okay, so that is what we wanted. It turns out this thing right here that kind of makes a mess of it also makes it become a perfect u substitution problem. So if in this step right here, you substitute these, then it is 1 over u du. Okay, all right. And I gave you the answer to that when I told you that form of integration is natural log of u plus c. And the u was chosen to be secant times tangent. So it's natural log of secant x plus tangent x. Okay, so that's how you do this one. And like I said, I know that most people are not going to think of that just out of thin air. But if I gave you that part in red, here's what I want you to see. If I told you this and got you to here, could you recognize it's just u substitution from that point? All right? That's what I want you to see. Now, okay, cosecant. Cosecant, you work this almost exactly the same way as that one, okay? It's so much the same, I just thought I would give you the answer and challenge you to figure out how you could get it, all right? But it will be natural log absolute value of cosecant minus cotangent plus c. It is, I mean, it really is almost identical to this one. So I'd see if you can fill in the steps, see if you can figure out what to multiply by, how you get a u substitution, and get to here, all right? Okay, so I'll leave that one for you, given that it's so much like this one. Let's do 2 more. Okay, so what about that one? And what about this one? Okay, all right. So here, I think, sorry, I forgot the dx. This seems like it's already in a form that can be simplified a little bit. All right. I could start thinking about identities that I could use, but why don't I just simplify it the way it is and see what I can do? Okay. I can't say that for every single problem there is a definite technique that you use exactly the same way every time. That's just not how it is. Okay. So, I mean, it's calculus too. You're going to have to practice, learn to be flexible, have a big list of derivatives and identities handy, and try to piece things together. It's like a puzzle to figure out, all right? But with this one, I think I'll just simplify it the way it is. Like, so this fraction could be separated like this. I could see it as secant squared over secant minus 1 over secant. Okay, so yeah, you could do that, right? Can't you subtract these back together to get there? You could look at that like a common denominator. Definitely, you can do that. But why separate it back out? Well, because I could see that these would reduce. What's secant squared over secant? That's just secant, okay? And what's 1 over secant? Is there what might possibly be a better way to write that? That's going to be cosine. Right? Now, did that get me anywhere? Did that do any good for me to do that? It might be, if I'm trying to work these, that I do something, and maybe that something is correct, but it doesn't get me to the point where I can work the problem. And what I mean is, if I don't know how to integrate this, then I haven't gotten anywhere. But we do know how to do that one. So I just told you about how you can integrate secant, and let's say that now that we've done that, maybe we can take that answer for granted. All right? And then cosine. Yeah, that's also easy. I can integrate cosine. So here's what we're going to get. The antiderivative of secant is natural log absolute value secant x plus tangent x. So we did that one already. Minus the antiderivative of cosine, that's just sine, right? Derivative of sine is cosine. All right, so it did work. Not everything I do is going to work. If I'm doing problems by myself, you know, I might make a misstep and it doesn't get me anywhere, but I'll eventually figure out something, okay? Here I just needed to simplify. All right, and I used an identity right there, 1 over secant is cosine. So maybe that one wasn't so bad then. So let's see, let's do this one now. Tangent squared, what about that one? Well, so this one as it is not u substitution. If you wanted u to be tangent, what would the du need to be? The du would need to be secant squared. So it's not u substitution. And it's not like this one where I can do any simplifying. Are there any identities you could use to reduce this and maybe get some form that you recognize? Well, tangent sine over cosine, okay? So you could say, all right, I think I'll do this. I'll say this is sine squared x over cosine squared x. But I don't think you'll get anywhere with that, all right? I just don't. You can try it. But unless that produces some form of integration you know how to do, it's not going to work. All right? So that's not going to work. What else is there? Tangent squared is secant squared minus 1. Okay? So maybe that would work. All right? I think that's the one. Okay, but let's say we consider both of those. This one I think will work, because I know the antiderivative of secant squared in 1. Here, I'm never going to turn that into u substitution or anything I know how to do. So here's what we're thinking about. We're thinking, could I use this? Could I use this? All right, well, that one's not going to work. This is the one that we want. Okay, so watch this. So tangent squared. Okay, so that's going to be secant squared take away 1, all right? And then the antiderivative of secant squared, that's just tangent, right? Because the derivative of tangent is secant squared. All right, that's fairly straightforward. For 1, we'll get x, and then we'll get plus c. End up being pretty easy, okay? But, all right, this whole video, I'm trying to get you to be flexible and think. If you're trying to solve a problem, you have to think of the stuff that's related to what you have. Identities. When I had this problem, I said, well, okay, what are the derivatives of the things that I have? And that allowed me to see that it was u substitution. And when we go all the way back to this problem, I thought about identities and derivatives of all the things that were involved, and that allowed me to realize that I could make it just u substitution. But that's the kind of thinking that you have to learn when you're in calculus 2.